All right, good morning, good afternoon, good evening, whenever you may be. Guess what? It's time for another exciting adventure into science, live from Ace Academy. Mr. Brenneman's science class, buried deep in actually, I've exited the Brenner bunker today. We're broadcasting from outside because conditions have finally started to relax a little bit here in the formerly totally quarantined Southeast. Now we're just kind of quarantined, but still. COVID is still out there. You guys still need to maintain your social distancing. I know you're probably, if you're traveling any places, you're seeing all kinds of people congregating and hanging around with each other and way closer than 6 feet. That's not what we're supposed to be doing. In science fiction terms, we call those guys red shirts. If I ever watches a Star Trek, will know exactly what I'm talking about. The red shirts were the guys that always went out with the original crew, Captain Kirk and Scotty and Spock. And those are the guys that always got killed. So when you see bunches of people out hanging out close to each other, just think red shirts. And those are the people that are being the test dummies for this new stage of COVID-19. So please don't be a red shirt. Maintain your social distancing 6 feet away. And if you're out someplace, please wear a mask. It just everybody's like, well, masks don't really block anything. Well, masks block the little spit particles that the virus is hanging on to. Yeah, it's not going to block the virus. Then it'll catch a bunch of those spit particles that it's, when somebody coughs or sneezes, that's what it's there to block. So again, it's just another layer of protection. Wear some sunglasses or glasses of some sort, because again, your eyes are a mucous membrane. Virus can enter it through the eye just like it can through the mouth or anything else. Don't touch your face. Well, I'm out by myself, so I can, but anyway. So today we're talking about renewable resources. And so today we're talking about natural resources. So it says I can classify renewable resources as either natural or energy producing. So today we're gonna concentrate on the natural side. Tomorrow we'll talk about energy producing natural resources, renewable resources. So yesterday we learned about natural resources, the difference between renewable and non-renewable. Today we're going to go into renewable resources. I'm reading down here. It says there are different types of renewable resources. We're going to classify them into two categories: renewable natural resources and renewable energy resources. Now, I'm the one making this distinction. So, because in the grand scheme of things, they're all renewable natural resources. But in order to make things kind of easy to talk about in class, we're going to call one renewable natural resources and the other one renewable energy resources. So just for clarity and just for these talking. So today we're going to talk about renewable natural resources. All right. So first we get down here. I don't have a mouse out here. So first we have what we're going to call our renewable natural resources. So these are resources provided by an environment that organisms use and rely on to live. These resources are air, water, soil, sunlight, and other living organisms. The air is a renewable natural resource. As I sit here and breathe, I am consuming oxygen and I'm putting out carbon dioxide. It's taking in the grass and the trees around me, it's taking in that carbon dioxide that I'm putting out, and it's using it in its metabolic processes and expelling oxygen. So right now, in the process of just living, me and the things around me are acting to renew the resource of air. Now, a lot of people go, well, air is free. Well, I've explained to many people many times, air is not free. Free air is what happens when you go to places like China, where it's all polluted and horrible, and you can't believe that people actually live there and breathe that stuff because of how bad it is. That's when people put no value on air and quote, it's free. No, it's not really free. It's just there's no value on it. But here in the United States, we put value on air. And so we do things to keep our air clean so that it's nice to easy to breathe and so that things don't die from consuming it. But as far as being a renewable natural resources, between the living organism and the plants that we eat, I breathe in oxygen and I breathe out carbon dioxide. The plant goes, oh, thank you, and takes the carbon dioxide in, uses it for its processes, and on the bottom of these leaves, there's this little thing called stomas, and these stomas emit oxygen into the air. So as long as things are in balance, as long as there's enough trees and enough organisms that are breathing in doing organic life processes, there's a balance between the two. And we have life will continue. So, next thing we're going to talk about down here is water. We're going to walk back here to where the water is. So I wander in the woods, and the camera goes, "Whoa, hey, where's Mr. Fermentarian?" We're just going to wander off into La La Land here. So now here's the thing with the last thing for the air thing. Right down here, it says, the cycle between both communities continuously renews the air for the other side. If either side has a serious die-off, the other side would be seriously affected. So all the organisms that live and breathe suddenly died off and stopped producing carbon dioxide. There would definitively be a drop-off in the ability of plants to live, because there wouldn't be such a ready, things out there producing carbon dioxide, which they need. Now, some carbon dioxide is put in the atmosphere by volcanoes and other natural processes, but plants and the animals, that breathe oxygen, have lived in a symbiotic relationship for many, many, many years. So you take out one side of that relationship, and it is not going to be good for the other side. Same thing applies to the plant side. So if we kill all the plants, guess what's going to happen? Carbon dioxide is going to build up in the atmosphere and have some bad effects for us as oxygen users, because there's not going to be enough oxygen by whatever's left. So the next thing we're going to talk about is water. Water, again, is a renewable natural resource. In nature, the water cycle cleans the water through a couple processes. First, when water evaporates, it leaves behind all the particulate contaminants it had in it. So remember, think about this. Boil some salt, make some salt water in a pot, boil it till the water's all gone. What are you left with? A white coating on the bottom of the pot. That's all the salt that you'd put in there. So when water evaporates and becomes a gas, whether it's by boiling or just the natural process of evaporation in the water cycle, it leaves behind all the contaminants that it had in it. It goes up in the atmosphere. It's a gas. Doesn't take any of the chemicals or particles or anything else with it. When it condenses and forms a cloud, it can pick up pollutants in the atmosphere. Now, again, frankly, by definition, if it's condensing, it's picked up at least a little bit of a contaminant, because it has to have a condensation nuclei. So, that's interesting. So it's by definition, it's picked up a little bit of a contaminant of some sort. So now rain, but once it picks up and becomes water again, then it actually can go through some other processes and actually become, in one case, it can pick up and become acidic. Some people, you guys have heard of acid rain. Acid rain is a real thing. The water, once it condenses into a cloud, becomes acidic by reacting with other gaseous pollutants that are in the air. So once those gaseous pollutants are in the air, they can react with the water and make that water move from being from being neutral, about 7, and make it acidic, which means the pH drops below 7. In worst case scenarios, they found rain that has a pH as low as 2, which is incredibly acidic. It's enough to kill trees and plants, things on the ground, and make the ponds and streams that water flows into unlivable. So that's definitely a purpose. Another way that rain can pick up contamination or pollution is that if you've had an radioactive industrial accident, such as Chernobyl or Fukushima, that has emitted radioactive particles into the air, and then the water vapor condenses around that radioactive particle, and then the rain is actually radioactive. That's happened a couple times as well. So just because rain falling out of the sky is coming out of the sky doesn't necessarily mean it's pollution free. It has fewer pollutants in it than it was if it was severely polluted laying in a puddle on the ground, but it still can have pollutants in it. But now here's the thing. When it falls on the ground, it flows into the creek and then percolates down to the ground. Oh, my background is kicked on. Hold on a second. Video. Choose. So when it falls on the ground and it percolates down, there we go. Sorry about that. So it falls down on the ground and it lands on the wood. So as the water lands on the wood, it soaks into the ground. As it soaks into the ground, it percolates down. Remember, percolation is when water moves through a porous, a seemingly solid surface that actually has micro holes in it. As it moves down through this porous surface, that is the floor of the forest here, it percolates down, and as it does that, it sheds the contaminants into the porous thing that it's flowing through. And over time, as the water percolates down through this porous surface and into an aquifer, say, it kind of cleans itself through this percolation process. Now, the only problem is, though, that when water does that, and it does have, contaminants that is picked up from the atmosphere in it, it leaves those contaminants right there at the surface. Right there at the surface. So the sand has, so if water fell on that sand, it would drain down to the sand. But if it had anything in it, that sand would pick up in the sand and would leave it in the sand as it flowed down into the earth. So now the only problem is now we've transferred that pollution from the water into now this sand that's laying here. So a lot of times you get areas where it's rained, acid rain or something like that for a long period of time, and then now the soil in those areas becomes acidic and has chemicals in it, the chemicals that were forming the acidity anyway, and it becomes an issue. So we shall move on. So now soil is a natural renewable substance. So we look over here. Right there is basically a lot of leaf and matter and broken up sticks and rotten wood and everything else. And so when we talk about soil being renewable, so soil is continuously produced by the erosion of rock and the breakdown of organic materials. Well, rock, when it breaks down, turns into sand. We got sand right here. Sand. So somewhere, upstream from where we are, there's been some rocks. And those rocks over the course of time have been broken down into the sand. So now let's take the sand, and then we have the organic forest that breaks down from the living trees and stuff that are around us. And so we take that soil, that sand, and that organic material as it breaks down, and we are creating more soil as we go. It is a naturally occurring regular process. Jump too far. So through composting and recycling of natural land coverings, when we clear the things to build on, we can actually create soil ourselves. So when trees are harvested for timber, when we clear up a piece of land and the rest of the organic material is ground into wood chips or stuff, and it's mixed in large batches with manure, poop from farms and stuff, we add sand to it that we get from other places, and we sell those things as topsoil and garden soil, like you've seen them in bags and Lowe's and Home Depot. So that's a human version of the natural process of soil renewal. Soil can be overused, though. So farmers figured this out thousands of years ago, that if you keep planting on the same plot of ground, the same crop, year after year, it starts becoming less and less productive. They figured out if you left a field unplanted for a year or so and plowed under the weeds and grasses that sprouted up, it helped out. This is called crop rotation. It was a major advancement in farming years ago. A little history there. But soil is a renewable natural resource because it is continuously happening right there. There's organic material breaking down. There's sand, and all these things, when they get together, are forming more soil. So the next thing we're going to talk about is that is a renewable natural resources as a living organisms. So here in the woods, obviously, if I sat here and sat still long enough, we might, start having some things kind of pop up or whatever. If I dig into the dirt, there's going to be worms and beetles and mites and stuff. And if we looked on the side of trees, there's probably ants and things running around as well. So all these things, all these living organisms that are here, and then just like, the whole entire, circle of life, smaller things get eaten by bigger things get eaten by even bigger things. And so the circle of life goes on. But given a normal balance of nature, the things are giving birth to things at a rate about equal to the things that are getting eaten by other things. So you have this balance that achieves itself. And so everything, serves its purpose, does its thing, and animals move on and live. So as long as, the key word being the balance, if through any process, natural or human induced, the balance is interrupted, the result can be the depletion of a resource. Remember, depletion is when you run out of something, even a natural resource like a tree. Trees are renewable natural resources. They grow regularly. But guess what? If you cut them down fast and use them faster than they grow, you are going to deplete that natural resource. Same thing with soil. All the nutrients in it to the point where it becomes useless, or B, cut down all the trees and let the water run off, take the soil, put it in the creek and run it out to sea as mud, you can deplete a natural resource that would normally be there. So all these things, it requires a balance in nature, a balance in how humans and other organisms interact in the world to maintain, these quote renewable natural resources. If we don't monitor the use of them and how things affect them and everything else, these resources will end up being depleted. It happens. So you have to pay attention to the balance of what's being used and what's being created. So the last thing we're going to talk about is sunlight. Yes, sunlight is a natural resource. It is the only true free natural resource. Again, when we talk about free things, a lot of people are like, oh, air is free. Again, you want to have that discussion, I will happily point out to you at some point how air is not free. Here in the United States, we pay a significant price in the cost of things day to day in order that we have air that is, All right, so we're back a little bit as we wander back in the house. I'm not quite sure if this is going to end up on the first video or not, but like I said, we will. The sun is the only true free natural resource. About 4 billion years old. It's going to last about another 5 billion years, and after that, it'll expand out to the size, about the size of the Earth, where the Earth is in its orbit as a red giant. Go another couple 100 million years and start and then blow off its corona, expose its core, which will heat up to about 100,000 degrees Kelvin, and then slowly kind of shrink into what they call a white dwarf stage, which it'll pretty much last the rest of its life. Anyway, so the sun is our truly one true free natural resource. Hope you guys enjoyed the lesson. Remember to like the video, and we'll see you guys next time.